Hello everyone, welcome back to my YouTube channel. Today we are going to learn Kruskal's algorithm, which is a graph algorithm which is used to find the minimum spanning tree, and it uses the greedy technique. Firstly, what is minimum spanning tree? Then we have to know what is Kruskal's algorithm. That is problem solving, and then the algorithm, and then its time complexity. So let us look into all of these one by one. Firstly, coming into minimum spanning tree, here spanning tree refers to a connected graph which has no cycle. Minimum spanning tree refers to when the weights of these spanning tree are added and it gives the minimum cost. So there will be many spanning trees. Among those spanning trees, which gives the minimum cost is considered as the minimum spanning tree. Coming to Kruskal's algorithm, we'll have an example graph. We'll solve it manually and then go to the algorithm. So the example graph is, so this is the example graph I have taken. So we have two steps in Kruskal's algorithm. The first one is sorting in increasing order. So let us write the edges which has the minimum cost in the beginning, that is BC has minimum 1, and then we have AB 3, we have BF 4, and CF again 4, FD 5, CD 6, AE 6. Okay, so we had two FE is 2, and after AE it is AF and DE both having 8. So once we have sorted all the edges, we have to start constructing a tree. That is, here we'll write the edge and here we will draw the tree. So first, taking BC, we will draw BC which has 1. Second step, take FE which is not connected to both of these, so we'll write it separately by writing BC also again. So we'll write FE here with 2, then we will take the third edge, that is AB. So since AB is B is already there, we can connect it here. AB and F will be written like this. So this is 3, 1 and 2. So now taking the next edge, BF, this is 3, this is 1, this is 4 and this is 2. Still it doesn't form a cycle. So we are keep on adding the edges one by one. By taking CF, that is here, it forms a cycle. So this is not taken. Let us skip that edge and then we'll take, this is F, D and then CD. So F, D, I'll be writing it here, but it has to be written again like the what I have written in the left side. So each edge, it has to be added with keeping all the edges the same again by writing it again. Since I have less space left here, I am writing it here. So if D is here, we are keeping the same positions of the nodes as it is in the given question. So here you can see it. If D is now 5, then we'll go to CD, which is 6. But if we take 6 CD edge, that is 6 here, that is here, then it will become a polygon, that is a cycle. That is why if D is taken, but CD is not taken. And then coming to the next edge, that is AE, it will form a cycle again, that is here ABFE, and again it will form a cycle. So let us skip that and we'll go to the next edge, that is AF. Again it will form a triangle here. AF is not taken. The last edge is DE. Again it will form a triangle, which is again a cycle, is not considered. So this is the minimum spanning tree. If we have to find the minimum cost, then we can add all these edges of the minimum spanning tree, that is 4 plus 4 8 plus 2 10 15. So minimum cost is 50. Now let us look into the algorithm. So in the algorithm, the first thing we have to write is the input, that is a weighted connected graph, that is set of all vertices and edges. In the output, we get the set of edges that forms a minimum spanning tree. Here we are naming it as ET. This is the set of edges of the MST. The first step what we did was sorting in non-decreasing order, which refers to increasing order. And then we are initializing few things. So these are the three things that are getting initialized. One is the set of all edges what we took it as ET is initialized to a null set. So null set is usually written like this, that is phi symbol, and the edge count, which is an integer, it is 0, and k is another integer which is 0. This is used for pointing it to the current edge, and this is used for making sure that we do not cross the number of edges. So we'll get to know why it is used. So this is the edge count, as the name itself says. So this is the edge count. Here we have that line where the number of edges in MST, so this is the edge count in MST, should be less than the number of vertices minus 1. What does it say is, if there are 4 vertices and in the graph maybe they would have given 4 edges, but if we have to find the minimum spanning tree of this graph, then we should have n minus 1 edge. So if we have a fourth edge here, it will become a cycle. For this to become a MST, we'll have 3 edges at max. So the number of edges in the MST will be always less than n minus 1, where n is number of vertices. So that we have written here using the while loop, that is while edge count is less than number of vertices minus 1, we will be incrementing the k, which is pointing to the current edge. So we'll go to each edge one by one, where this points to the current edge. That is used here. That k value, the index is used here. We have to then check if it is cyclic or acyclic. So if the union of the MST edge and the given graph edge is acyclic, then we are taking this union, the whole union, as an edge in MST. And then we'll be incrementing the edge count by 1. Then we have to return the ET, that is the edges in MST. So coming into the time complexity now, the time complexity of Kruskal's algorithm is big O of number of edges log number of edges, which is same as n log n, where n refers to number of edges. Hope you have understood the algorithm. I'll be posting a similar question, a graph like this, in the end of the video. So please solve that and let me know in the comment section the minimum cost that I have calculated here for that graph. And thank you all for watching. For more such videos, please subscribe to my channel.